B cells are a type of white blood cell, or lymphocyte, that are part of the immune system and play an important role in fighting infection in the body. In B-cell malignancies, these cells malfunction and become malignant. They reproduce at an abnormal rate and can compromise the immune system. Comprising non-Hodgkin's lymphoma and chronic lymphocytic leukemia, B-cell malignancies are diagnosed in approximately 100,000 in the US each year and cause 25,000 deaths. Several cellular pathways can contribute to the development of B-cell malignancies. These pathways include B-cell receptor pathway and BCL2 pathway, which can promote the survival of malignant B cells. The B-cell receptor pathway, or BCR pathway, is an essential signaling pathway for normal B-cell development. It is triggered by an antigen binding to B-cell receptor on the membrane of the B-cell. BCRs bound to the antigen aggregate together with immunoglobulin components CD79A and B, and recruit non-receptor protein tyrosine kinases, LYN, and SYK. They amplify BCR signaling, which subsequently initiates PI3K, a protein that converts PIP2 to PIP3. Phosphorylated PIP3 recruit AKT. AKT promotes cell proliferation and activates mTOR complex, which leads to resistance toward apoptosis, or programmed cell death. BCR pathway regulates itself through multiple methods, including inhibitory enzymes. However, dysregulation of BCR pathway can contribute to cell growth and resistance to apoptosis, leading to B-cell malignancies. The proteins involved in the BCR pathway, including BTK and PI3K, are therefore targeted in a number of clinically validated therapeutic treatments of B-cell malignancies. B-cell lymphoma 2 family, or BCL2 family, is a protein group that consists of proteins that either promotes or inhibits cell apoptosis. Among them, BCL2 is a type of anti-apoptotic protein that inhibits cell death. When the cell needs to go through apoptosis, BCL2 is inhibited by BAD, or BCL2-associated death promoter, binding to block its anti-apoptotic effect. One of the ways the cell can prevent apoptosis is phosphorylation of BAD by PIM kinases. When PIM kinase is hyperactivated or overexpressed, BCL2 can become abundant and continues to promote cell survival, thus contributing to cancer development. Therefore, BCL2 pathway is targeted in a number of clinically validated therapeutic treatments of B-cell malignancies. When both BCR and BCL2 pathways contribute to the cancer development, targeting only one pathway may be ineffective, as the other compensates for the inhibited pathway to promote cell survival and evade therapy. IBL-202, a first-in-class dual inhibitor, in preclinical development by Inflection Biosciences, inhibits all isoforms of both PI3K and PIM kinases. It uniquely inhibits both BCR and BCL2 pathways at once, via dual PI3K and PIM kinase inhibition. This in turn, reduces proliferation of B cells, combats resistance, and induces greater apoptosis in these cancer cells, compared to targeting either pathway alone, and may ultimately represent a new treatment option to extend patient survival.